Hi, this is Denisa, and in this video I'm going to go over how to write some code to show that this expression here, a index n plus 1 divided by 6, where a n is equals to this expression here, is a perfect square. Now I've derived this coding challenge from a website called Codebymath. It's a website where you can learn code in the context of learning math, and I recommend you go check it out. Now this website uses Lua, but I'm going to use Python because that's what I'm learning. Okay, so ignoring the second part of this expression here, we can go over this bit. So an, it says here, is equals to a index n minus 1 plus a index n plus 1 divided by 98. So it's a recurrence because it refers to its own values, and we know that a0 and a1 here is equals to 5. So I'm going to go over the first iteration, which is a1. So when n is 1, we know that an minus 1 is equals to 5 because a index n minus 1 is equals to a0. We're just gonna write that down here first. And an plus 1 is equals to a2 because a1 plus index plus 1 is 2, and divide by 98. Now we can substitute this for the values we already know. So a1 and a0 is 5. So 5 equals 5 plus a2 divided by 98. And so we have one unknown value, and we can work that out now by multiplying 5 by 98. Take away 5. That's equals to a2. So we now know if you put this in the calculator, it will evaluate to 485. So we can just code that for a bit. I'm going to code that. So we know that an in this case will be a1, so it will be 5. We also know that an minus 1 is equals to 5 because that's a0, and we want to work out what an plus 1 is. That's a2, so we just insert the expression that we use here. So an multiplied by 98, take away an minus 1, and if we print an plus 1, we should get 485. Okay, so you have 45 here, so you know that's an minus 1. So what you want to do next is do the next iteration of a, so it'll be a2, right? And a2 minus 1 is a1, and a2 plus 3 is a3, and you divide it by 98. And again, you know the value for a2 because we just worked that out. That's 485. And you know the value for a1, which is 5. And you just want to work out the value for a3. We'll substitute that. 485 is equals to 5 plus a3 divided by 98. And we want to work out a3, so 485 multiplied by 5, multiplied by 98, take away 5, is equal to A3. And we can work that out programmatically. We can eventually we want to do this for A4 as well. So A4 would be A3 plus sorry, we want to do this for A3. So A3 would be equals to A2 plus A4, and we'd work out A4, and then we'd work out with A4, we'd work out with A5, and etc. etc. So you want to do this, and then eventually you'll be able to so you want to do this, and eventually you'll be able to get all the values for the expression that we had earlier, that was an plus 1 is equal, divided by 6 is equal to perfect square and such. So we're going to put this in a for loop where n in range, we can pick anything for now, but sorry, we have to pick anything, any range, but it has to start from 1 because it's above it's above 0. Okay, so you have this, and what you want to do in here is you want to store the value here and put it in the next an, so that A1 here goes to here, and A2 here goes to here. So your new an will become an plus 1. And you want your an minus 1, that is this value here, to become the previous an. So an minus 1 is equals to an. So what is happening here, if you just go over here, so you find out the value of A2 here, that's the first line, and then you switch your minus 1 into here, and your an plus 1, which is the 2 here, into the an, and then you're going to do this again for A3, A4, and etc. So we can see that sort of in action here. You can print out the iteration number, and then you can print out the an minus 1, and then an and an plus 1, just so that it goes up in order, and you can like print it after you do the first iteration. Okay, so we can see this. Alright, so we know now that A3 is 47,525. Alright, so now what we want to do is evaluate the second part of the statement. Using a for loop, show that A index n and then plus 1 divided by 6 is a perfect square. So this value plus 1 divided by 6 is a perfect square every time if it's above, if n is above 1. So we can do that by taking our result and adding it. So we have a new result is equals to n plus 1 divided by 6. And then we can print that out. And we can print we'll run this. And I can't really tell if these are squares, but I know for sure that 1 and 81 are perfect squares. So we want to get the root square, and if they're perfect squares, they all should be integers. So result to the power of 0.5, which is the same as getting the square root of a number. And we're going to print the root square alongside that list. Alright, and for the first two, 1, obviously the root square of 1 is 1, then 9, and you know from these that they all are also perfect squares. Alright, that's it. That's how you do this challenge from Codebymath. Thanks for watching, and go check out Codebymath.